So Jordan, since you're in the power generation business, I just thought I'd show you what my little summer project has been here. There's lots of talk about all the green energy stuff that people are interested in, and most of it's arrogant BS, and so is this probably. But here's my little summer project. I developed a little powerhouse here on the ranch, and we ran off of spring-fed water sources. Here's the output from the powerhouse. It comes out of the little culvert here. And then I'll take you over and give you a quick tour of the inside of it. This is the power going out to the Spencer house that uses power. On the right, the magnet sign is a 4,400 watt inverter, sine wave inverter. And then in the middle here, we just have the power panel that gives me some instrumentation so I can tell what's going on with the systems. And then as I turn to the right here, it's our spare parts department, and a 24 volt battery that we use. It's actually a retired forklift battery. And you can see the three pipelines bringing the water in from the springs. And I'll try to give you a view of this one. Actually is collected from a pond, and it's very low pressure. It's only about 25 to 30 pounds, depending on the level of the pond. The second one here runs from one of the springs where we collect water, about 78 pounds usually. And the third one comes from a different spring source, about 60 pounds normally. Then swinging around to the left, you get to see the source of the power actually comes from three little micro hydro turbines. These are Pelton wheel style turbines that run with permanent magnet alternators, and then are rectified into DC to store in the batteries. The one on the right produces somewhere between 200 and 260 volts, three-phase, and I send that on three number 6 wires, 2,200 feet to the house that we're supplying with it, and then we transform it down to 24 volts nominal and rectify it to DC to store there. The one in the two on the left both supply the closer house here, and they produce power that goes in this battery that we just looked at. Up above is just the transfer switch boxes, and the center right box is actually a volt control switch, and what that does is kicks on these. I just use standard irrigation valves, 1-inch valves, and so on demand, as soon as the voltage goes down to 25 volts, it opens up more jets and kicks our amperage way up. We're running about 14 amps on these two alternators as just a float charge, and then as soon as the switch calls for more power on demand, they kick up to about 45 amps, 24 volt. Then the controller box on the left is simply a charge controller, which bleeds off extra power if the control switch fails and puts too much power on the battery. It's actually a fairly simple little system, but very effective, and it's been a heck of a lot of fun to build this summer. It's been my summer project. This is what I do for entertainment. Some people go to ball games, and I play with Hydroelectric. You can see on the gauges up here, one of the battery packs is running at 78.9, or yeah, 28.9. Pretty close to starting to bleed off some power with the charge controller. At 28 volts, it'll start bleeding off. And then over here, this is the system that's sent remote to the other house. And this one shows 24.5 volts. It's actually about a 2-volt drop because of the distance in the line on this one. So at the batteries, it's more like 26.5. And then the upper gauges just show me line voltage at the system over there. And this one is the 3-phase wild cycle that feeds across to the battery pack. And the bottom one is just the voltage on the batteries. So, that's the news from Kilowatt Dan, the dangerous power man.